Woohoo, we're live. This is Math 60, which is Intermediate Algebra, Chapter 6, page 3, page 2, wow, my nails need a little work. I guess just biting them is not sufficient. But, here in the apocalypse, we do what we can. So for rational functions, the poster child is this guy right here. F of x equals 1 over x. This is like the basic rational function. And I'm going to go ahead and graph this. And I encourage you to pull out Desmos. I'll remind you that that is an app and a web page. You can look it up as an app or a web page, and it is absolutely free online graphing. Now, if you don't want to go to that much trouble, you can also just Google 1 divided by x, and Google will give you, at least at the time when I'm recording this, Google will give you a graph. I have no idea what's going to happen after the apocalypse. Who knows? Maybe there will be free food and shelter for everyone. I mean, maybe could happen in healthcare. Might happen instead of just free graphs, because not that I don't appreciate free graphs, but not the most helpful thing in the world. But the world we're living in right now, no free food, no free shelter, no free healthcare, but free graphs. So I don't know. Maybe one of my possible existences lives in the world where there's free other stuff. Okay, but I digress. So basically I would use Desmos. However, let's say you're stuck in a YouTube video with no graphing technology whatsoever, and you really need to graph this. What would we do? Well, the first thing we would do is we'd curse the person who printed the graph at the top, because now we're going to have to go to the bottom to do our work. Okay, curse, curse, curse. There's a lot of cursing in Chapter 6. I think Chapter 6 really deserves a lot of cursing, if we're honest, right? Okay, so if I've got f of x equals 1 over x, the first thing I might want to do is set up a table of values. And the very first thing that I do is I always tell you, let's always try x equals 0. And here it explodes. Pew, pew. Oh no, flying spiders, terrible things. Not that I think spiders are terrible, but I've always thought that flying spiders would be like really the sign of the apocalypse. And you will get flying spiders if you try to plug in x equals 0, because then we would have 1 over 0. Oh no, it's undefined. Run away. Okay, so we get our first restriction there without even trying. Basically, don't let x equal 0. Okay, let's try x equals 1. Y is 1 over 1, which is 1. Awesome. X equals 2. Y is 1 over 2. This is like the easiest thing I've ever done. 3, 1 over 3. Yay, 4, 1 over 4. So notice what's happening to y. Y starts at 1 and it gets smaller, but it stays positive. If x is 10, y is 1 over 10. Okay, that's pretty good. X is 100. I can't graph x equals 100, but let's just look at it. 1 over 100. That's teeny, right? 0.01. Oh, you can't even see it. There we go. See, one of the signs of the apocalypse, videos don't even show you what you're supposed to look at. 1/10 is 0.1. So these things are small. Okay, that's fun. But this is only some of the x's. I might want to look at some other x's, and I used up all my space. See, my spatial understanding is just rubbish. Let's try down here, though. Again, in the apocalypse, we do tables of values wherever we can. I'm going to try -1. 1 over -1 is -1. -2. 1 over -2 is -1/2. I see a pattern here. -3. 1 over -3. -1/3. -4. 1 over -4. Oh, sorry. I jumped the gun there. I'm giving answers away. But basically, it does exactly the same thing, but in a negative way. Okay. Now, normally this would be enough. You guys would be like, oh my gosh, that's so many points. Yes, and see, I have some improv in my background. Yes, and I orange you. I hated that one. I orange you too. What if x is 1/2? I had to bring that up, didn't I? And then everyone's going to go, oh no, we have to remember how to deal with complex fractions. Oh no, oh no. 1 over 1/2. What the heck is even going on here? And I'll remind you that that is 1 divided by 1/2, which is 1 times 2/1. Remember, they flip fractions. When you divide fractions, you flip them upside down. If you don't know that already, you know it now. I have just told you. When you divide by a fraction, you flip the fraction. Okay. 1 times 2/1 is 2. Ah, it flips upside down. So what is this? What is this function where y equals 1 over x? It means y is the reciprocal of whatever x is. So if x is 1/3, y is 3. If x is 3, y is 1/3. They switch places. See how that works? If x is 1/4, y is 4. So now what's happening is x gets really, really small and close to 0. Y gets really, really big. Interesting. Now I've got a couple questions for you. X can't equal 0. Can y equal 0? And this is one of those stumpers. Maybe you want to stop the video and go lie under a tree somewhere in the, well, not if it's raining. That's not a good idea. But if it's sunny outside, go lie under a tree and with a little piece of grass in your mouth, looking all bespoke and country-ish, and you think, can y equal 0? Can any of us really ever equal 0? And the answer is no, not in this case. None of us can equal 0. Nobody gets to be 0 in this one. Because let's take a look here what's happening. As x gets bigger, y becomes 1 over whatever x is. So x could be like 1,000,000. And then y would be 1 over 1,000,000, which, to try to guess how small that is, imagine you had 1 pizza and 1,000,000 people to feed. And you are not a demigod or god. This was going to be a tricksy case. 1 pizza, 1,000,000 people. Imagine how much you're going to get. It's going to be a little tiny bit. Okay, so y can get very, very small, but y can't be 0. Interesting. So the domain of this is that x can't be 0. And the range is that y can't get to 0. Okay. Graphing this is tricksy. I'm going to throw caution to the wind and just put my axes right in the middle. I'm going to regret. I know I'm going to regret. But I think, again, we've covered the fact that this chapter is basically a chapter of regret. Because we say rational expression, so you won't notice that I think you figured it out. This is an entire chapter on fractions. More fractions, harder fractions. Yay, everyone's favorite. Imagine if there were fraction word problems. That would be ridiculous, right? There's no way we would do that. Let's not talk about it anymore. Okay, so I'm going to come back down here. I'm going to remind you of a few things. When x is 1, y is 1. When x is -1, y is -1. So the ones all match. What does that mean? When x is 1, y is 1. And when x is -1, y is -1. Which makes me want to connect the dots, except no zeros. We cannot touch the x-axis. We cannot touch the y-axis, right? This is the place where y equals 0. This is the place where x equals 0, so we cannot touch it. So these two, this is like a Daniel Day-Lewis movie. My gosh, if this video remains, if it sticks around for 10 years, 20 years, I wonder if anyone will know what that is. I don't know. Insert your favorite overacting, scenery chewing, romantic lead person. Stay alive, no matter what happens. I will find you. They won't find each other. They never touch each other. They never get back together again. It's okay. It's for the best. Really, each of these points needs to go off and find their own section of the graph to be in. Trust me, it's good for everyone. Okay, so I'll remind you again down here. I have these memorized, but I want to keep reminding you. When x is 2, y is 1/2, 3 1/3, 4 1/4, right? They're reciprocals. So at this point, you're going to look at me and go, wait a minute, this is going to be impossible to graph. And I'm going to say, yes, that's why I recommended you use Desmos to begin with, because humans can't graph this very well. But when x is 2, y is 1/2. When x is 3, y is 1/3. Now, obviously, I'm not measuring this. This is hard to graph. So this is just going to be kind of a sketch. All graphs that humans make are sketches. There are no humans, well, I shouldn't say no. There are very few humans, none that I've ever met, who can draw a graph as well as a computer. Computers are fast and they're precise. Humans are easily distracted, and we would much rather be playing Minesweeper. It's possible that computers would rather be playing Minesweeper, but the thing is about a computer, it could also be playing Minesweeper and graph at the same time. So different situation entirely. Okay, now we're going to have to use our imagination. Let's go into imagination land. Imagination land says when x gets really big, y gets really small, but does not get to 0. So as I move out in this direction, what's going to happen to y? Y is going to go really, really small. I'm going to turn this side. Well, no, I'm going to turn myself sideways. Sorry. And do this. And then I'm going to write something very rude because I haven't explained anything. So have you ever wondered what they do with all the spare letters that we have in the alphabet, like the letters that no one ever uses that much? They put them all into math words. I contend that this word is impossible to actually be pronounced, that everyone who tries to pronounce this either spits or they don't pronounce it correctly. The word is asymptote. I just had to spit. The x-axis is the fence when this gets really, really small. So this part of the curve gets really close to the x-axis, but doesn't touch it, doesn't go over it, doesn't bump into it, doesn't anything. It just keeps approaching it. That makes the x-axis the asymptote. The fence is the asymptote. That's important to remember because some people think this is the asymptote right here. The curve itself is the curve. The asymptote, sorry, no one can pronounce this. I wasn't kidding. The asymptote or asymptote, if you feel like it, is the boundary. It's the limit. It's the fence. It's the wall. It's the thing that says you shall not pass. Okay, next up. There's no speaking friend in this one. Okay, I'm going to go to this section right here. What happens when x gets very small on its way towards 0? The answer is y gets very big. So let's try to figure this out. In teeny tiny vision, if this is 1/2, 1/2 is right there, then y will be 2. When x is 1/3, y will be 3. When x is 1/4, y will be 4. Now, do you see what's happening on this side? Same thing. Notice what, oops. And here's where being human sometimes sucks. I can't, this is a pen. It's hard to draw this. But basically, it should be like a little swoopy doopy guy. We'll look at it on Desmos in just a second, and I'll show you a beautiful picture of it, right? Yes, exactly. I will show it to you. I am pulling it up as we speak. Oh, that's lovely. Let me do 1 divided by x. There we go. Can you kind of see that? That's the beautiful swoopy doopy that it does. Isn't that beautiful? And the benefits of Desmos are you can stretch it out or squish it down, take a look at what's happening. But you can see that asymptote. In fact, I shouldn't have looked so soon because I just blew the surprise of the fact that the other half of our separated lovers, they never do get back to each other. They live their own lives. It's okay. It's okay. He wasn't right for her. He really wasn't. He wasn't. And it was also, an appropriatively confusing and questionable movie as well. Okay, so let's look at what happens in the negative land. If this is an asymptote, y-axis is an asymptote. The way that I do it to avoid spitting is I don't actually say the P. That's very, very popular. People say asymptote rather than asymptote, which then I've got like 48 T's, and that's just not necessary. Thank you, Mrs. Fujikawa, my choir teacher, for teaching me to pronounce every single letter that I can find. Sometimes I'll be out on the street and I'll just be, sitting tall. Well, I'll be standing tall because you can't sit back in a chair after you've taken choir. And I will pronounce every letter I see with the and it, and I will make sure I'm breathing at different times from everyone else. It's exhausting, actually, to be a choir student. Okay, so let's look at what happens. As x gets more and more negatives, like to -2, -3, y gets smaller, right? Let's take a look down here. As x goes from -1, -2, -3, -4, y is going -1/2, -1/3, -1/4. So y is getting closer and closer to 0, but from the bottom side. Does that make sense? I hope it does. So we end up with this little swoopy doopy guy, which I kind of already showed you because I showed you the graph too soon. But basically, the x-axis is also an asymptote, but this guy's approaching it from the bottom, which is kind of cool because they're going. Okay, now with a graph like this, there's pretty much only one option. It's got to do this, but let's double check. As x becomes, let's imagine fractions that are negative. So seriously, bunny hair, it gets everywhere. If x is -1/2, y, which is the reciprocal, is -2. -1/3, -3, -1/4, -4. Bam. So here, as x gets, like there's -1/2, y is -2. -1/3, y is -3, and so on. Look at this guy. Wow. It's kind of cool, isn't it? It's almost cool enough to, actually give this guy a name, which we may or may not do in your next class. That's it. I would encourage you to graph it. I would encourage you to use Desmos, take a good look at it, get to know it, make friends with it. Those of you going on to calculus, yeah, this is your life now. But it's not all terrible. Sometimes things will not be, well, sometimes things will be a lot worse. And this, you'll look back on this and think, oh, wasn't that lovely? So there you go. This is the graph of f of x equals 1/x. Now here's a cool thing to know. What if I had x minus 1 in the denominator? Okay, if I had x minus 1 in the denominator, that means x can't be 1. Where's my fun note? I was looking for paper, but I thought I would just do it here. If we wanted to graph f of x equals 1/x plus 1, notice that x cannot be, oh, I said negative, sorry, I switched it. I'm like that. I'm just, I just spontaneous. That's it. I'm super fun because I'm always spontaneous. Mathematicians don't ever plan things out. We are not boring. We don't need things a certain way. We're not obsessive maybe much. Okay. So what if I have x plus 1 in the denominator? That means x can't be -1. So you take this graph that we've got, and if you find x equals -1, then the whole thing goes around here. The whole thing just shifts so that the vertical asymptote is at x equals -1. Super cool, huh? And so if this were x minus 1, we would shift the vertical asymptote over here to x equals 1. So, but that's for your next class. Woohoo! Okay, done with graphing these bad boys. Now we're going to go back to, I don't know, something else. I'm sure it'll be exciting. Okay, see you soon.